Solve using the quadratic formula. All right. So if you have ax squared plus bx plus c equals 0, then x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And this period is not part of the formula. It's the sentence if then. Okay. So ax squared, that a can't be 0 or it won't be a quadratic. That's why it's called that, because it's got the x squared term there. All right. So when an equation of degree 2 is set equal to 0 and cannot be factored, use the quadratic formula. Notice I said it cannot be factored. If it can be factored, I'd much rather factor it. But I am actually going to do an example just to show you, hey, it's the same thing. It doesn't prove anything, just whatever. B squared minus 4ac, that's the stuff under the radical here. That is known as the discriminant. If the discriminant is positive, then there are two real solutions, right? The square root of a positive number, right? And then you get negative b plus that number minus that number equal, over 2a. If the discriminant is positive, there's 2. Note, if the discriminant is a perfect square, then it can be factored. So if b squared minus 4ac is 49, for instance, or 64, then it can be factored. So you should have factored it. If the discriminant is 0, there's one real solution. And if the discriminant is 0, then it can be factored, because then it would just be a repeated root like x minus 1 squared or whatnot. And then if the discriminant is negative, then there are no real solutions. The answers are complex or imaginary. And in this case, those two imaginary or complex solutions are called conjugates, where you get 3 plus 2i over 4 and 3 minus 2i over 4. All right, so let's look at some examples here. X squared plus 8x plus 12 equals 0. Now, this particular one, you say, I can factor that into x plus 6 and x plus 2. You sure can, okay? So if I solve that, I get negative 6 and negative 2. So I want you to file that away in your memory banks. I know I skipped a bunch of steps, didn't show anything there. If you factored it, you would end up with negative 6 and negative 2. So guess what we should get if we solve using the quadratic formula? We better get negative 6 and negative 2, right? I'm not proving that it works, but I'm just showing you an example of one that factors and it turns out to work correctly. So what we're going to do here is it's all equal to 0. We need to identify A, B, and C. And then I have actually taught this both ways, where you have to know the formula to take the test and where I give you the formula. So just to make sure you're prepared, every single time you work a quadratic formula problem, write down the equation, the formula. Write it down every time. Write down x equals, make your big fraction line. Notice, don't do this. Students do that all the time. The x equals is not part of the fraction. That is not just wrong, it's wrong wrong. It's spelt wrong, it's so bad. All right, negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so notice some things here. I don't have this. And what I mean is, see how my fraction line goes out past the c there? See, this one doesn't go far enough, so you don't know what really is under the radical and what's not. The other thing is, I don't have this. The students do this all. It drives me crazy. All right, and they do. No, this thing right here should go all under everything, the fraction line. Those are all details. Again, the details matter. That's why you take math, in my opinion. I know that some of my math teacher friends will get mad at me saying this, that, I should know the math. No, some of them are going to need to know the math, but some of you, the next time you see this is going to be when your kid's in 9th grade or 10th grade and taking algebra in school, and you're trying to help them. Okay? But what you are going to see every single day of your life, no matter if you stay at home, work, don't have a job, do have a job, big job, little job, important job, not important, that you might think is important. They're all important if they need to be done. Okay? All of them. So, look, pay attention to detail, be efficient, and be a problem solver, not a problem creator. All right? Those things will help you in every aspect of your life, no matter what you become or what you do. No matter what. Okay? So those are details. Make sure your fraction line's horizontal. It's far enough left and right. It's under everything. The square root goes over everything, right? All those things. X equals is out front. So now identify A, B, and C. A is the thing times x squared. So what is the thing times x squared? Well, if you don't see anything, it's a 1. What's the thing times x here? Notice I circled the plus sign because that's part of it, 8. Now, 8's understood to be positive. I'm going to put plus 8. But it's 8. And then what's the C? That's this one. That's going to be 12 in this case. Again, understood to be positive. So I have x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Write it down every single time. Identify a, b, and c. Now we come over here and say x equals, and I'm going to put negative b plus or minus the square root of b squared minus 4ac. Notice, see, I extended my fraction line and radical over 2a. Notice every time I read a letter out, I put parentheses there. It's not necessary. I can put a dot or I can just write something down. Depends on what it is. But I'm going to write that every single time I have a variable to fill in. So b, this is b, that's 8. This is b, that's 8. This one's a, right? This is b, b, a, c, a, right? So a is going to be what? 1, and c is going to be 12, and then 2a is 1, right? So I'm going to get rid of this and then get rid of these, but that's what I'm plugging in there. So now let's start simplifying this. X equals, and we have negative 8 plus or minus the square root of 8 squared is 64 minus, go ahead and do that. What is 4 times 1? It's 4, and then 4 times 12 is 48. All over 2 times 1 is 2. So now the thing that we need to do next is combine those things. 64 minus 48, which is negative 8 plus or minus, is still not, you still have not taken the square root. Leave the radical there. That's still under the radical, so it's the square root of 16. Do I know what the square root of 16 is? Yes, I do. That's 4, okay? And you know what it is too. Negative 8 plus or minus 4 over 2. And here's where you can do some different things here. You can either write two equations at this point. That's what, actually at this point, that's what I would do. I would come up here and say, okay, this is going to be x equals negative 8 plus 4 over 2, or x equals negative 8 minus 4 over 2, right? We said plus or minus, so one of them is plus 4, one of them is minus 4, and everything else is the same. So this one, let's go ahead and solve it. Negative 8 plus 4 is negative 4 over 2, which is, guess what? Negative 2. And then over here, this is x equals negative 12 over 2, which is negative 6. And that gives me x equals negative 2, or not. I picked the pen up, but anyway, negative 2, comma, negative 6. So x equals negative 2 or negative 6. If we factor it, we get the same thing. That's why I would never, ever, 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 ever use the quadratic formula whenever it factored, because I was done in factoring in like 14 seconds. And then this was 14 years later, okay? I have more gray hair after working this problem because it took so long, okay? So I would never ask you to do this. I want to show you this so that I can say, hey, this is the same thing as if we factored. Didn't prove anything, just made you feel more comfortable maybe with it. So, but that was a lot of stuff, okay? That was a lot to do there. So as we go through these, let's look at the next one here. X squared minus 6x minus 10 equals 0. So it's equal to 0. I can't factor it. Factors to 10 that's subtracting me 6 can't happen. So I need to identify A, B, and C. What is A? 1, B is negative 6, and C is negative 10, right? A is the thing here, 1. B is the thing times x, that's this negative 6. And then C is the thing by itself, the negative 10. Then I'm going to come over here and say, okay, x equals, and what's my formula? Remember, x equals is not part of the fraction. Negative b plus or minus the square root of b squared minus 4ac over 2a. Now, I have students who do that to get under my skin because I tell them make sure the fraction line is long enough. Don't be ridiculous with this. We're going to fix this. We're going to come up here and shorten it up a little bit, right? But notice this stops, right? The line goes further out than the radical, okay? That way there's no doubt what's in the numerator, what's in the denominator, what's under the radical. There's no doubt whatsoever. So now if we start filling this in, x equals, and I'm going to go negative and then parentheses for b, right? And then plus or minus, that's plus or minus the square root of b squared minus 4ac, right? Parentheses for all my variables, 2a. So what goes in this first one? B is negative 6, and here's negative 6. And then A is 1 for those two, and then C is negative 10 for this one, right? So really, when you have negative B right here, that really just means change the sign. That's what a negative in a formula always means, is change the sign. It doesn't mean anything else other than change the sign. So, right, because when you say negative times a negative, you get a what? A positive. So this is going to be x equals 6 plus or minus the square root of what? Negative 6. of the utmost importance you put that in parentheses. That is not negotiable. Negative 6 without parentheses squared is negative and then 6 times 6. It's not negative 6 times negative 6. It must be in parentheses, okay? I don't care. President, Pope, your teacher, me, anybody. I'm not holding me to a different standard. If I don't put that there, see, this means negative 6 times negative 6, and that is 36. This means negative and then square the 6, and that's negative 36. I don't care who you are. This is correct. This is the only correct, whether I do it or somebody else does it. I don't care. If somebody writes this and means this, they're wrong, period. And I know that's not nice or whatever. I'm not trying to be ugly, but that's just wrong, okay? So you got to put the parentheses around it. So this is positive 36, and then negative 4 times 1 is negative 4, and then times negative 10 is plus 40. That's plus 40. And then we have over 2 times 1. So then this is going to be x equals 6 plus or minus the square root of 76 over 2. And the only thing we need to do is, can we simplify? And I need to fix this just a little bit here because that was a little too long. All right. We need to see, can we simplify this? Is 76 a perfect square? No. 64 is 8, 81 is 9, and 76 is in between 64 and 81. So it's not a perfect square. Is there a perfect square that divides into 76? And the answer is yes. What I mean is 4, 9, 16, 25. Those are my perfect squares. Do any of them divide into 76? Yes. 76 is 4 times 19. Right? 4 times 20 is 80, and that's 1 less 4. 4 times 19. So the reason that matters, the square root of 4 can come out as a what? A 2. So what I'm going to do, I'm going to come over here and say this is going to be x equals 6 plus or minus 2 square roots of 19, because I did the square root of 4 times 19, right? That comes out as a 2, and then that stays under the radical, over 2. And you cannot cross these 2's out because you have 2 terms up here. You can never cross one term out of a string of terms. A string of terms, I'm saying 2 or more terms. You can never cross one term out of multiple terms, ever. Okay? You can, however, factor this up here if it has a common factor, and it does. It has a common factor of 2. It's going to be 3 plus or minus the square root of 19 all over 2. These 2's divide out, and I have x equals 3 plus or minus the square root of 19. The reason you could do that, this 2 is times. See the parentheses around all this? That's completely factored. When it's completely factored, you can then divide out something that is factored out by the denominator if it's one term. So then x equals 3 plus or minus the square root of 19. So that not only involves a quadratic formula in my view, in the way I view the world, it also involves, can I simplify a radical, which is something involved in this, but it is a totally different concept. Okay, not totally different. It's related in the sense that you're using radicals, but it is an additional concept, I should say, an additional concept. But it is part of this. You have to be able to simplify radicals to do the quadratic formula. The quadratic formula part was to get down to right here, okay, and then simplifying it uses other techniques, but that's what math does, right? It builds. So you learn something and then you use it with something else. So let's look at this one here. Is it equal to 0? The answer is no. So I need to move this over because I want to keep my x squared positive. So I'm going to subtract 2 from both sides. That cancels over here and gives me 0. And then I have 5x squared plus x minus 2 because descending order is the way to go. But if I try to factor that, it's not going to factor. So I need to identify A, B, and C. A is 5, right? What is B? 1. The thing times x is 1. What is C? What is the thing by itself? Negative 2. And then I say, okay, my quadratic formula x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to write it down every single time I work a problem. And then if I still don't know it, I'm going to write it down 5 times a day until I take my test. And that's for anybody in anybody's class that has to memorize it. It won't take you 3 minutes to write that down 5 times. But if you did that Monday and then opened your notebook up Tuesday and did it, and then Wednesday and then Thursday and then Friday and then Saturday and then Sunday, and I know I said the weekend, it's okay, you can do it. All right? It only takes a few minutes each day. And look, quite frankly, like most of the time when this is on one of my tests, there's about 4 or 5 or maybe 10 other formulas they have to know. Well, so now you're up to 10 minutes of writing formulas every day. But guess what? If you just spend 10 minutes a day, you will not forget them. And you're taking a test, for crying out loud. Why would you want to forget them? Because if you don't know the formula, you're going to miss it. It's worth 10 minutes a day. That's your job. When you're in school, your job is to do well in school. Okay? So if you don't do well in school, then that speaks to what you're going to do later in life when you get a job. That's why they have letters of recommendation and all that kind of stuff. You need to be thinking about that when you're taking people's classes. Because one day you're going to graduate and want somebody to write you a letter, and if you were a slacker the whole time, who's going to write one? Not a good one anyway, right? So think about those things. Sorry, that was a life lesson from Mr. Guest moment. All right? So 5x squared plus x minus 2 equals 0, and then we have our quadratic formula written down. So now we're going to say x equals, and I'm going to have negative b plus or minus the square root of b squared minus 4ac. And look, as you become more familiar with this over 2a, you can start to say, okay, negative of b just means change the sign. Don't write negative in parentheses and write it in there. You can skip that step. That's fine. But until you get familiar with it, do this every time. Every time. So b is 1, a is 5, and c is negative 2. So then x equals, and we'll start to simplify this, negative 1 plus or minus the square root of 1. 1 squared is 1. And then 2 negatives is positive. 4 times 5 is 20 times 2 is 40 over 10. So then x equals negative 1 plus or minus the square root of 41 over 10. All right? 41 is a prime number. It won't factor in. It's not a perfect square. So guess what? You are actually done with this one. This is my favorite kind right here, because there is no simplification going on. This problem here tells me, does my student know the quadratic formula and how to use it? If I wanted to know all the other stuff, I test can you simplify radicals, the very first test in college algebra, and the other test in other algebra classes. All right? So I already know if you know how to do that. So here I'm not going to muddy the water. I'm just going to say, hey, can you do this right here? That's my personal opinion. Okay? You do need to know how to continue if it goes further. But for the purposes of do you know how to do the quadratic formula, this serves the purpose, in my opinion. That is very rare in the math teacher world in my experience. Most of my math teacher friends cringe at me saying that. Oh no, they should be able to do and simplify and get all kind of crazy stuff. I know, I've already tested to see if they can do that. Okay? So x squared minus 2x plus 17 equals 0. Won't factor. It's equal to 0. So I need to identify a, b, and c. What is a? It's 1. Negative 2 is b, and c is 17. So then x equals, we get negative b plus or minus the square root of b squared minus 4ac over 2a. So then x equals negative, and then b plus or minus the square root of b squared minus 4ac over 2a. And b is negative 2. A is 1 and C is 17. So we get 2 plus or minus the square root of 4 minus, over 2. 4 minus 4. Look, 4 times 1 is 4, and then 4 times 17. I do 4 times 10 is 40. 4 times 7 is 28. That's 68. And that equals x. And then x equals 2 plus or minus the square root of negative 64 over 2. Now, if we're talking about real numbers, if we're talking about real values, this doesn't work. You cannot take the square root of a negative with real numbers, right? But with complex or imaginary numbers, then you know the square root of negative 1 is I, right? The lowercase I. So what we're going to do is say this is x equals 2 plus or minus. The square root of a negative is I, and the square root of 64 is 8 over 2. So then I'm going to come up here, and I'm going to do that factoring thing again. I'm going to say 2 times 1 plus or minus 4i, right? I took a 2 out of both of those terms. Got a 1 and a 4 over 2. And now this is factored, so I can cross those out. They divide out. That divide does not cancel. No current math book that I have in my office says it cancels. 30-year ago math book in my office says it does. Okay? All your teachers were taught by somebody who was taught it canceled, most likely. unless they're really, really young, okay? And out of books that said that. I was taught that way. But it really doesn't cancel. It divides out. So then that becomes 1 plus or minus 4i. And that's a fine answer. I wanted to point out, I didn't point this out earlier. 1 plus 4i is an answer and 1 minus 4i is an answer. Those are two separate answers. So, but we can write plus or minus. So we are getting two answers there. And those are conjugates, as I mentioned earlier, when the discriminant is negative. The discriminant there is negative 64, right? The thing under the radical. So 1 plus or minus. Again, that's simplified some, okay? So I'm doing these because that's the way many of my math teacher friends like to do it. And so I'm going to make sure that my video incorporates these things in there for sure, right? X squared minus 2x equals 1. So again, I got to move this over. I'm going to subtract 1. Then put it in descending order. There are no factors of 1 that subtract to give me 2, so it won't factor. So A, B, and C. What is A? 1, negative 2, and negative 1. So then my quadratic formula looks something like this. Negative B plus or minus the square root of B squared minus 4AC all over 2A. And again, notice how I extended those lines to make sure that everything was fully under the radical. Everything is fully in the fraction. The x equals is not part of it. So then again, as you become more familiar, you can skip some of these steps, but negative b plus or minus the square root of b squared minus 4ac over 2a. I would even practice saying it as I wrote it. I mean, the more times you say it, the more times you write it, the less chance you got of forgetting it. You're taking a test. It's worth it. It's worth it. So then b is negative 2, a is 1, and c is negative 1. So negative of negative 2 is 2, plus or minus the square root of. This is 4, and then plus 4, right? 4 times 1 is 4, and it's negative times negative, all over what? 2. So let's just come over here. I'm kind of writing this one big. X equals 2 plus or minus the square root of 8 over, I don't know what I've done here. I didn't left my equals off. 2 plus or minus the square root of 8 over 2. Can I simplify the square root of 8? Well, yes. This is 4 times 2 into the radical. That comes out as what? So 2 plus or minus the square root of 4 is 2, and this 2. This 2 is left under. That 4 comes out there, right? That's where I get that from, over 2. And so again, I want to factor this 2 times 1 plus or minus the square root of 2 over 2. And then that, since that's factored, those divide out. And x equals 1 plus or minus the square root of 2. 1 plus or minus the square root of 2. And then this is the last one, so I'm going to use I like this green. 4x squared minus 4x minus 1 equals 0. It's equal to 0. What's A, B, and C? A is 4, B is negative 4, and C is what? Negative 1. In my quadratic formula, I'm going to write it down. X equals negative b, no parentheses there, plus or minus the square root of b squared minus 4ac all over 2a. And notice I extended my radical to make sure that it covered everything of the b squared minus 4ac, so there's no ambiguity whatsoever. X equals negative, and then b is negative 4 plus or minus the square root of b is negative 4 squared minus 4a is 4, and c is negative 1 all over 2a is 4. And again, I extended my fraction line and my radical to make sure it encompassed everything it should have. All right, so then this is going to be x equals 4 plus or minus the square root of 16 minus, no, plus 16, isn't it? 4 times 4 is 16 times 1, and then negative and negative is positive over 8. So this is going to be x equals 4 plus or minus the square root of 32 over 8. And 32 is 16 times 2, right? What's the square root of 16? 4 in the radical, right? The 2 stays under the radical, and the 16 comes out front as 4, because the square root of 16 is 4. You applied the square root of to the 16 to get the 4. You couldn't apply it to the 2, so you have to leave it under the radical over 8. And then I can come over here in some space and I say, okay, only because I ran out of space. You don't have to always come over in space. But then 4 can be factored out. 1 plus or minus the square root of 2 all over 8. And then that becomes a 1 over 2. So x equals 1 plus or minus the square root of 2 over 2. So I think I did a good mixture there of problems that simplify down pretty good. That way you are familiar with that process. And you already know how to do that, but it looks a little funny with the plus or minuses in there and everything else. And just one little side note again, this is really 1 plus the square root of 2 over 2 and 1 minus the square root of 2 over 2. It's two separate answers. I want you to understand that, but we write it with plus or minus. Okay? So I hope this helps you when you solve using the quadratic formula.